तुम्ही सुरुवात करा. करा, करा, करा. नाही, हा ऑन झाला.
Hello, hello.
Good morning, all of you. I request all the students to put your mobile phone on silent during the program. Thank you. I request once again, put your mobile phone on silent during the program.
A very good morning to all of you. We have today gathered 2 days international conference organized by the Science Department of the DP Bhosle College, Koregaon. Today we have here the chief guest, Professor Dr. P.S. Patil, who is virtually present among us. Then President of the program, C.D. Lokhande, sir. In our today's 2-day session, we have the Professor Pramod Patil, sir, Pro Vice Chancellor, Shivaji University, Kolhapur. Welcome to all for the 2 days international program of the science conferences we have organized here. The delegates on the behalf of the national and international conferences organized by the DP Bhosle College, Koregaon. The Department of Physics, Chemistry organized a 2 days international conference on the topic Emerging Trends in a Material Science. The Department of Mathematics and Statistics organized a national conference on the topic of the recent trends in mathematics and statistics. Again, the Department of Zoology and Microbiology organized a national conference on the topic of the innovative trends in biological research. The Department of Botany organized a 2 days international conference on the topic of emerging trends in plant sciences, biodiversity, conservation, and environmental sustainability. A very special thank you for all the gracing this special occasion with your esteemed presence. Welcome to all the participants. Welcome to all the students. A very good morning to everyone present over here. I take privilege warmly welcome to all dignitaries on the behalf of the national and international conference organized by the various departments of the DP Bhosle College, Koregaon. The physics and chemistry organized an international 2 days conference on the topic of the emerging trends in material science. The mathematics and organized a national conference on the topic of the recent trends in the mathematics. Then Department of the Zoology and Microbiology National Conference on the topic of the innovative trends in the biological research. The Department of Botany organized a 2 days international conference on the emerging trends in a plant science, biodiversity, conservation, and environment sustainability. A very special thank you all of the gracing this special occasion with your esteemed presence. Welcome to all dignitaries. Here today we have the principal, Dr. V.S. Sawant sir, Professor Dr. P.S. Patil sir, who virtually present with us. He is the chief guest of the today's session. Professor Dr. C.D. Lokhande sir, Director, CIR, D.Y. Patil University, Kolhapur. Dr. Nanasaheb Thorat, Scientist, Oxford University, London, UK. Dr. Pranav Katkar, Research Scientist, Sanjog University, South Korea. I welcome to all the dignitaries. I would like to request all the dignitaries a special thank you for all gracing this special occasion. And here I would like to request that to come forward lighting the lamp, and also would like to request to offer the flowers to the Karmavir Bhaurao Patil. Offering prayers to Almighty, we are having our customary lamp lighting ceremony for seeking the choicest blessing of the God and make this program a successful one. I would like to request our Honorable Principal, Dr. V.S. Sawant sir, our Chief Guest, Professor P.S. Patil, Pro Vice Chancellor, Shivaji University, Kolhapur, and our President of the program, Professor C.D. Lokhande sir, Director, CIR, D.Y. Patil University, Kolhapur. We extend a very warm welcome and request you to please. The lamp lighting ceremony is a start, and now they offer the flowers to the Karmavir Bhaurao Patil. Offering prayers of Almighty, we are having our customary lamp lighting ceremony for seeking the choicest blessing of the God and make the program successful of one. The all dignitaries, they have lighting the lamp. Please give the big hand. Here may I also specially welcome to all the scholars, all HODs, professors, faculty members, and students of the various departments of the esteemed audience who have gathered here from the various or diverse places. Again, I request to all dignitaries, please have a seat. I hope that all of you will have the 2 most productive days of the interesting and stimulating discussion. I sincerely wish that this conference will be the great success of his, not only as an opportunity to share the knowledge and experiences in a higher education, but also a beginning of the long and fruitful cooperation and friendship among the fellow educators. Now, I would like to request our college principal, Dr. V.S. Sawant sir, please come on the stage and give the introduction about the 2 days international and national conference organized by the DP Bhosle College, Koregaon.
On behalf of DP Bhosle College, Koregaon, and as a chairman of organizing committee, I welcome the distinguished speaker, guests, delegates, and students who have enrolled for these different, were coming from the different places to grace the 2 days hybrid board international conference on emerging trends in material science, organized by Department of Physics and Chemistry. Second, hybrid mode international conference on emerging trends in plant sciences, biodiversity conversion, and environment sustainability organized by Department of Botany. National Conference on Recent Trends in Mathematics and Statistics organized by Department of Mathematics. And the next National Conference on Innovative Trades in Biological Research organized by Department of Zoology and Microbiology. We are proud to have the chief guest of inaugural function, Professor Dr. P.S. Patil, sir, Pro Vice Chancellor, Shivaji University, Kolhapur. Today's president of this function, Professor Dr. C.D. Lokhande, Director, CIR, D.Y. Patil University, Kolhapur. Professor Dr. Nanasaheb Thorat, scientist from UK. Sandeep Golab, scientist from Katkar from Korea, for taking time off from their busy schedule to inaugurate this 2 days hybrid board international conference. Other dignitaries, resource persons, and participants from all over the country among us today. On the behalf of DP Bhosle College, Koregaon, I welcome you all at this inaugural function of all conferences. Our college is established in 1968. We provide quality education in science, arts, and commerce, computer application, BHOC stream. At present, 3,960 students are studying in this college with 16 undergraduate and 7 postgraduate programs. Besides, the college offers career orientation, certificate programs, and short-term courses. Our college has been accredited A grade with 3.12 CGPA. It also certified with ISO 9001:2015. We have got a notable success in academic, culture, and sports events. Friends, to upgrade the knowledge, I will suggest you to get involved in active research. Research should be our passion. Don't do it only to get certificate or good job or to get high API score. Do it to make your career. Select only one topic. Go on doing it with new technologies. As a technology changes, don't change topic. Just modify your way to doing experiment as per new technologies. Do this exercise continuously. I am sure at one day you will come up with a wonderful and novel idea. The need of today's research is interdisciplinary work. The output of good research can come up if you have knowledge of all fields. You should know physics, chemistry, computer, and even biology also. One person can't handle all these areas, hence to work in collaboration and in a group. Considering all these things, we have organized this event for the budding research scholars, faculty, and students. I am sure that the resource persons will provide a useful guideline to the researchers. The discourses and the lectures delivered by these expertise will be fruitful and helpful. The presentations of research papers and discussion on it will be also beneficial to all of you and to the society. Once again, I welcome you all over college and hope that you will have very exciting and enriching academic sections. Wish you all the best. Thank you.
Thank you, sir. Now I would like to request Professor Dr. S.B. Jadhav, sir, please come on the stage and give introduction of the chief guest and president of today's program.
Good morning. Dignitaries on the dais, Honorable Principal Dr. Sawant sir, Honorable Speaker on stage, Professor Dr. C.D. Lokhande sir. Online mode, I would like to welcome Professor Dr. Pramod S. Patil, who is Pro Vice Chancellor, Shivaji University, Kolhapur. Katkar sir and Thorat sir, you might have been witnessed 2 days back on Sahyadri channel. He was interviewed and spoken about recent advancements in cancer research and technology. So at the outset, I would like to welcome all of you, and I would like to introduce Professor Dr. Pramod S. Patil, resume very briefly, because 5 pages data is there, quite big data. All personalities have tremendous weightage of research. So very briefly, I would like to introduce Professor Pramod S. Patil. He had worked about 31 years in teaching as well as research experience. His major area is energy storage devices, batteries and supercapacitors, chemo-resisting toxic gas sensor, electrochromic, smart window coatings, nanofabrics, and nanomaterials. He has about 492 international papers and published 5 patents. He has also produced 44 PhD students, and he is recipient of prestigious DAD Fellowship of Germany. Currently, he is working as a Pro Vice Chancellor of Shivaji University, Kolhapur, and he had individually taken about more than 15 research projects funded by national and international funding agencies, major thrust area, nanobiotechnology, and so on. He had guided 48 students, 43 completed, 1 submitted, 4 are still working, MPhil also 6, and more than 200 projects at MSc level have been completed under his able guidance. So he had also received prestigious awards. List is quite big, but I would like to highlight only few. That is, he had worked as an editor in material science, Hindui Publishers, Indo-Singapore International Conference, and so on. So very much proud feeling that quite best research work he had done. Second dignitary on the dais, I am very much honored to introduce him also, Professor Dr. C.D. Lokhande sir. His native place is near Maswad, Piliu. He is belonging to rural areas, and his title of PhD thesis is Photoelectrochemical cells formed with aluminum doped cadmium sulfide thin films. In 1984, he had submitted his thesis. He had written about 15 books, review articles 17, international journals, publications 718, papers presented at seminar symposia 550, total citations more than 32,188. So quite big number. Total citations, H index, he had published about, taken about 63 patents. Indians, they are 40 accepted, Korea, then 8 accepted, applied for 15 Indian patents also. So at present, he had MOU with Stanford University, USA, then Germany, and so on. I would like to highlight one more thing. He is a recipient of Alexander von Humboldt Fellowship of Germany. And I think he had taken it for 5 times. So this is very much creditable thing. Student guide, he had guided more than 57 students for PhD work. Still there are 8 students, they are working. And research collaboration is concerned, Florida University, Korea Institute of Science and Technology, Hanyang University, Gifu University, Japan, University of Nigeria, and Bengu University, Nigeria. I would like to also introduce very briefly about Dr. Nana Sahib Thorat, who is from Maini near Vita. I am personally very much proud. His recent area, at present, he is working in University of Oxford, Medical Science Division, University of Oxford. He had overall 7 years research experience, more than 3 years teaching experience, patents, European patent, one, 5 books, book chapters 20. He had also innovations 2, total citation more than 3,200, H index 35, and research fellowship and grant received to him. Please give him big hand, more than 10 crore Indian rupees. So you are very much lucky, you are very much fortunate. You should interact with them personally. As far as poster and other activities are concerned, try to interact, speak with them. And I am once again, welcome to all of you. And I hope this international conference will be definitely fruitful to your future career. Thank you very much.
Thank you, sir. Coming together is a beginning. Coming together is a beginning. Keeping together is progress, and working together is success. The most awaited occasion is finally here. I'm much delighted to offer a hearty welcome to all the people gathered here to inaugural function of the BP Bhosle College, Koregaon. It's indeed a proud moment to all of us. The one who acts as a pillar of support and strength with clear vision and passion, intertwined with novelty in all the activities of the college, is our principal, Dr. Savan Sahib. Staff today, Professor Dr. P.S. Patil, our Vice Chancellor, Shivaji University, Kolhapur. So, unfortunately, you are not available with us here, but the internet made it possible to connect virtually. I hope you accept our kind regards, and it is a delight honor to have you here. Good morning, sir. Good morning, sir. Unfortunately, you are not available with us here, but the internet made it possible to connect virtually. I hope you accept our kind regards, and it is a great honor to have you here. Thank you, sir. Moving ahead, I would like to request Principal Dr. Savan Sahib to felicitate the president of today's program, Professor Dr. C.D. Lokhandi Sahib, Director CIR, D.Y. Patil University, Kolhapur, by giving him a bouquet, shawl, and a memento as a token of love and respect. I would like to request Savan Sahib by giving him a bouquet, shawl, and a memento as a token of our love and respect. Thank you, sir. Now I would like to request Principal Dr. Savan Sahib to felicitate our keynote speaker, the first keynote speaker, Professor Nana Sahib Thorat, scientist, Oxford University, London, UK, by giving him a bouquet, shawl, and momentum. Thank you, sir. The next keynote speaker, Dr. P.P. Badgakar, Emeritus Scientist, NCC Pune, is present with us virtually. I would like to warmly welcome you, sir, and thank you for your attendance. The next keynote speaker is Dr. Pranav Katkar, Research scientist Sejong University, South Korea, by giving him bouquet, shawl, and momentum. I would like to mention two keynote speaker, that is Dr. Sandeep Gholap, scientist, Saudi Arabia, and Dr. Fabian Izlima, Professor, University of Nigeria, Nasuka, are present virtually. I would like to warmly welcome you, sir, and thank you for your attendance. Thank you once again.
Thank you to all and thank you to ma'am. Today, we are organized a conference on both online and offline mode. May I would like to request Honorable Chief Guest Professor Dr. P.S. Patil sir, Pro Vice Chancellor, Shivaji University, Kolhapur.
I would like to request Principal Sir, Jadhav Sir, to felicitate our Principal, Dr. Saban Sahib, by offering a beautiful flower. Thank you, sir.
Thank you, sir. Thank you to all. Today, we have organized a conference on the hybrid mode, both online and offline mode. May I would like to request Honorable Chief Guest, Professor Dr. P.S. Patil, Pro Vice Chancellor, Shivaji University, Kolhapur, please give your valuable speech on the occasion of the national and international conference.
Am I audible?
Professor Dr. P.S. Patil, sir. Yes, sir, you are audible. Professor Dr. P.S. Patil, sir. Sir, please unmute your mic.
अनम्यूट केलेला आहे. आवाज येतोय का?
Yes, now you are audible.
Okay. Good morning to all of you. The president of today's function, Dr. Shivankar, Secretary, Rayat Section Samstha, the principal of this college, Dr. V.S. Sawant, convener, Dr. V.S. Jamdade, the eminent invited speakers who have gathered over here, Professor C.D. Lokhande, Dr. Nana Sahibji Thorat, Dr. P.P. Vadgavkar, Dr. Fabian, and all other eminent resource persons, and my dear participant friends. I'm indeed very happy to be here on the occasion of inaugural function of 2 days international conference on emerging trades in material science, organized by Department of Physics and Department of Chemistry, D.P. Bhosle College, Koregaon. In fact, material science is an interdisciplinary branch, and therefore I am very happy to note that both the departments, physics and chemistry, they have come together to organize this conference. Today, as we know, that we have a plethora of renowned, eminent speakers who are going to talk to you in the afternoon, and you will also get an opportunity to interact with them. All these are very eminent speakers, and I'm sure they will cover most of the important aspects related to the material science. I am here to tell you something that are very useful, that is very useful as far as material science is concerned. I'm going to tell you something related to the elements and the materials which may be called as a super elements or super materials. In short, because I've been given only 15 minutes, though I am expert or have done a lot of research work related to solar cells, supercapacitors, gas sensors, and electrochromism and nanofabrics, I am going to tell you something else than my research work, which is really useful. This is really important for all the youngsters to know about. So let me start with one important and useful gadget that we are using in day-to-day life, and that is the smartphone. What are the materials and what are the elements that are used in the smartphones so that we are today using the smartphones without knowing which materials are there and which elements are there inside the smartphones that we are using day-to-day life. There are several precious materials which are used in the smartphones, like lithium and cobalt are useful in the batteries of the smartphone, lanthanum, yttrium, terbium, dysprosium. All these are the elements. Half of the elements in the periodic tables are there in our own smartphone that you have to realize. In addition to all these elements, we also have copper, silver, platinum, and silicon. These materials and these elements are also there in our smartphone. Each element has a unique role to play, making our phone slimmer, smarter, and more powerful. But the only one other material, which is called as a gold, is also there. So if I take, suppose if I take 1 kilos of a smartphones, there are 300 times more gold than a kilo of a gold ore. That means there are a lot of gold which is also available in our smartphone. And all these elements, they play a unique properties, they play unique roles in our smartphones. But I'm going to emphasize more on another very important element or the material, which can be called as a super element, which is also there in our phone. This element or this material is responsible for making our phones into smartphone, and that is indium. So this indium is called as super element because if I make indium oxide and dope it with tin, it is called as a ITO. And this is ITO. Because of this ITO, all the phones have been converted into the smartphones. We could eliminate the use of keyboards in our normal phones, and we can use the touch screen. And the material which is useful for making the touch screen is the ITO. And without this ITO, our smartphones would not be more powerful, would not be more useful. And therefore, this indium is called as super element. So we have also done a lot of work in ITOs, and we have fabricated the indium tin oxides in our laboratory. This is really a revolutionary. But one man who has recognized the importance of this ITO and utilized this ITO, indium tin oxide, in the smartphone. And the first phone was launched in the market in the year 2007, and that is called as a Apple iPhone. And the person who launched this iPhone in the market for the first time in the world is Steve Jobs. And because of that, entirely new industry was created, and the demand for the indium increased to a larger extent. And therefore, this is a rare element with magical properties, which has replaced the keyboard phones with the smartphones. And therefore, this ITO has got unique properties, like it is a transparent and conducting. If I look around, then you can see that the materials which are conducting, they are not transparent, like iron, copper, zinc. They are conducting, but they are not transparent. And the materials which are transparent, they are not conducting, like glass, quartz glass, etc. They are transparent, but not conducting. So indium tin oxide has the unique combination of transparency and conductivity. And therefore, indium plays a very, very important role in our smartphone. As I told you, the entirely new industry has been created, and many people are now buying smartphones rather than the normal phones with the keyboards. And therefore, it is necessary for us to look what will be the problems in the future if we continue to utilize the smartphones, because every person, every student, every person is now in need of smartphone. If I tell you that indium reserves on the earth is very limited. Indium is tightly bound to the zinc. And if I take a zinc out and dissolve it in the acid, heat it and add some chemicals, you get very small, minuscule amount of indium from the zinc, which is tightly bound to zinc. And therefore, it is very difficult to extract indium from the zinc, and there is only limited amount of indium on the planet Earth. Normally, in one smartphone, we use 0.029 grams of indium. Today, 1 billion smartphones have been sold. That means we have already exhausted 700 tons of indium, which is already there in the planet Earth. And the geologist has calculated the total amount of indium on the Earth, and that is around 16,000 tons. And at the rate of 700 tons per year, we will that indium will vanish in the next few years. And therefore, before it ends, we have to search for the new materials which are useful for the smartphones. Today, there is no problem, but tomorrow there will be the problem because indium is going to vanish from the planet Earth very soon. And therefore, we have to focus our research on finding out new materials which can replace the screen, which are conducting and transparent, and which are having more better properties than ITOs. And therefore, it is our duty and responsibility to undertake the research related to this. So this is one super element that I wanted to tell you. The another thing that I wanted to tell you is another super element, which is called as a rhenium, which was invented in 1925, which is very tough, which is durable, and which can withstand at a very, very high temperature. And because of this rhenium material, we got a cheaper air travel. Because this rhenium material, since it can withstand a very large amount of heat, has been utilized to manufacture the rocket engine or the aeroplane engine. The high-tech engines can be manufactured only with the rhenium, and those are called as the turbo engines. And because of these turbo engines, the fuel efficiency increases and the air travel becomes cheaper. And therefore, today, we can afford to travel from one place to another place by using aeroplanes. Otherwise, before the invention of rhenium, the air travel was not that cheap. But this rhenium invention has translated this particular travel very, very cheap because it can withstand high temperature. And in the turbo engine, the high temperature propels the turbines at a high speed, and that thrust that gives thrust to the rocket engine. And not only that, it also increases the fuel efficiency. This rhenium, therefore, is called as a super element. However, from where we get rhenium, most of the rhenium on the planet Earth is again, it is a limited, and 50% of the rhenium is going to only one company, that is called as a Rolls-Royce. The high-tech engines are manufactured by one company in the world, that is Rolls-Royce. So half of the rhenium in the world goes to that particular company, and that is also going to vanish very, very soon. Very importantly, and funny part of this, that some people have found that it is a waste product from copper mine. If I extract 1 ton of copper, you get only half a gram of rhenium. Therefore, it is very, very rare, but very useful. And its availability on the Earth's crust is very limited. And therefore, we have to search for some other material which can replace rhenium. But another problem that comes up here is even in aeroplane, we rely on burning the fuel, because without burning of the fuel, we cannot create the energy. From many years ago, from historical times, we have been burning fuels, coal, oil, and gas for getting energy. But as we know that burning the fuels pollute the air, pollute the atmosphere, and pollution is again the next major problem that we are going to face. And therefore, we have to find out some other alternative to mitigate the problems of pollution of the air. And environmental degradation is one of the important problems that we are going to face in a near future. As we know, in order to mitigate the problems of the environmental degradation, we have to utilize non-conventional energy sources like windmill or wind energy or photon energy and so on and so forth. And therefore, a lot of research in the country, in the world, has been focused on the invention of novel devices so they can utilize they can avoid the problems of burning of the fuels. So can we generate energy without burning fuel? Yes, we can generate the energy without burning of the fuels. And one such example is windmill. Windmills are you might also seen in and around Satara, there are a lot of windmills. But have you thought that what are the elements, what are the materials that are there in the windmills? Most important material that I'm going to tell you today, which are useful in the windmills and they are using in the windmills. You know, the principle of the windmill, you can spin the magnet into the coil to generate the electricity. You can spin the magnet by using or by burning the fuel, or you can spin the magnet with help of wind energy. But there is another problem. If the wind speed is not enough, the turbines will not rotate and energy production will stop. And therefore, we have to design the windmills so that they can rotate even at the lowest wind speed and it can generate the electricity. That was the problem. As you know, you might have seen the windmills, they are very, very huge machines and it is very difficult to maintain. If something goes wrong, you have to climb up on the windmill and repair that. And it is very, very tedious and complicated job to repair the windmill. The most of the problem that is now available in the windmill is the gearbox. The gearbox fail. The failure of the gearbox is frequent and therefore it is necessary to maintain the windmills frequently. And that is the problem. But this problem has been removed with the use of one other super element, which is called as a neodymium. Neodymium is a super magnet. It has a strong magnetic power and it can replace the gearboxes. And without gearboxes, you can just use neodymium magnet. It can start generating electricity. Okay, so even though the wind speed is very, very low, with the help of neodymium, you can generate the electricity even at the low speed. So today you can also take a survey of the windmills in your region at what wind speed they can generate the electricity. So these are some of the important aspects of neodymium, which can create the electricity at a very, very low speed. But again, if there is no wind, there is no energy. And therefore, whatever the energy that we create, we must store that energy. And when it comes to storage of the electrical energy, that can be converted into chemical energy, and you can store the electrical energy into the chemical energy with the help of another super element, which is called as a lithium. Today, lithium batteries are everywhere. So lithium batteries are the secondary batteries. They can store the electrical energy and they can deliver electrical energy whenever we need it. Even in our smartphone, we have lithium batteries, and the lithium batteries, it can be scaled up and can be able to store the lot of energy. So whatever the electrical energy that we create with the help of windmill can be stored in the lithium battery. Not only that, today, this is the era in which we are also looking forward to have electrical vehicles. So these electric vehicles are also in a position to utilize these lithium batteries because they can be charged again and again, used again and again without going waste. And therefore, lithium is another material which can complement the windmills which can store the electrical energy in the form of chemical energy. But only thing is that there is one problem with the lithium also. This lithium is very rare. When you combine lithium with the cobalt oxide, it is lithium cobalt oxide that is the most important battery electrode which is used in the lithium battery. But this lithium is very, very rare. And another problem is that half of the world's lithium is found in just one place, and that is Bulgaria, that is in Russia. So that particular country has having a half of the reservoir of lithium. And therefore, we need to find out some other element for the battery electrodes. And we have to find out some elements which are abundantly available, like sodium, potassium, and so on and so forth. So tomorrow we have to do a lot of research and find out sodium battery, do a lot of research and find out potassium battery, because sodium and potassiums are abundantly available. Though the researchers across the world have demonstrated that sodium and potassiums can be utilized in the batteries, there are still a lot of problems. There are still a lot of disadvantages and limitations. We have to break the bottlenecks for conversion of these sodium and potassium into a battery. And therefore, this research is going on to a larger extent in the world. Another most abundant material which is available on the earth that we have to search and convert that material or utilize that material into a device to generate electricity, and that is hydrogen. Hydrogen is most abundantly available on the earth, and therefore it is very necessary for us to fabricate or to do a lot of research and viable and commercial research to develop hydrogen fuel cell, because hydrogen fuel cell can generate electrical energy. So hydrogen is going to be a next generation fuel in future. Lot of research is going on in the field of hydrogen fuel cell. Not only that, another device which can convert the photon energy into electrical energy, because we need electrical energy abundantly. In our house, if I see, all the appliances are run on the electrical energy. So we have to tap all the resources and convert those resources into electrical energy. The photon energy, fortunately, we are blessed with a lot of sunlight, and therefore we have a silicon solar cells. Solar cells are the devices which can convert photon energy into electrical energy. However, again, the solar cells are a little bit costly, and therefore we have to choose another materials, another elements which can replace silicon or make silicon cheaper, so that the conversion of photon energy into electrical energy would be more cheaper, would be more useful. And therefore, our research should be focused on most abundantly available materials, but there are problems, and therefore we have to switch to the materials, though they are rare, but they are precious and they have unique magical properties that it is very difficult to replace those materials like indium, rhenium, and neodymium. And therefore, these windmills currently are, of course, utilizing this neodymium, but in complementary with windmills, we have to do a lot of research in the solar cells, lithium batteries, and hydrogen fuel cells. Another material which is called as a super material or super element is helium. As we know, when we liquefy helium, we can utilize that liquefied helium in MRI, medical resonance imaging. It is useful for the health monitoring. You can have a brain injury to cancer diagnosis with the help of MRI. It is a super fluid. It has no friction when it is a super fluid. It is the coldest in the universe. Its boiling point is 3.6 K. So this also helium can be classified into super element in the periodic table. So again, helium comes from just one place in America, and therefore helium store is about to finish, and we have to search another material and replace helium with another material. These are some of the challenges in the field of material science. The last material I am going to tell you is about the tungsten. which is also called as a super element, is the tungsten carbide. When tungsten is mixed with the carbon, it is tungsten carbide. That is the magical material. It is a very super hard material. You cannot destruct the material, and therefore it is called as an indestructible material, tungsten carbide. But the problem is that only China can supply or was supplying this tungsten carbide, because the reservoir on the planet Earth was found only in China. China was supplying tungsten carbide to rest of the world till 2010. And immediately China found that there is something wrong, and therefore they restricted the supply, and the restriction of the supply from China to rest of the world sent shockwave in the world, because all of a sudden there was a shortage in tungsten carbide, and it was very difficult to manufacture the tanks and other military devices like machine guns and missiles and so on and so forth. So because this tungsten carbide is indestructible material, it is super hard material, it is the most useful material in the world. But fortunately, the solution was found in UK, and now we have some reservoirs in the UK. Therefore, even though China has stopped the supply, the UK, we are getting tungsten carbide supply from the UK currently. So, in short, I'm not going to tell you, I'm not going to take a lot of time. These are some of the elements and materials which are necessary, and therefore we have to focus our attention to do research in this to replace these materials and find out some other materials which have similar properties. Some 50 years ago, the population of the world was around 3.5, and today it is 7 billion. All are buying, 7 billion people, all are buying the stuff like smartphones, windmills, and solar cells and all this. All these people are buying the stuff that require us to dig up more and more minerals to keep up to the demand. Till now, there is no problem, but we have only one earth, and sooner or later,
Hello, sir. Unmute yourself.
फोन कॉल आला होता मध्येच. ऐकू येते?
Yes, yes. Now you are audible.
Okay. Sorry, there was one phone call in between, so the connection got lost. So what I was telling you, we have only one earth, and if we keep on digging our earth, very soon we will end up into some problems. And therefore, NASA is doing research on how to mine into the space, how to mine onto the moon and asteroids, so that we get a continuous supply of these super elements. One thing history teaches us, when the demand is big enough, we tend to find the solution. And ultimately, I am optimistic, we should be all optimistic that we can avoid this running out of the stuff on which we rely on using better design, better efficiency, and much more efficient recycling, and maybe even space mining. So probably we have to also undertake some of the events related to space mining, but it is very, very costly affair. The country like India may have some other options and may have other alternatives to focus on that. So most of the developed countries like America, they are attempting to keep ready to mine into the space. So that may be the solution to the running out of the super elements. Another very simple solution for replacing the super elements is to watch the nature very carefully. You can learn the lessons from the nature, because there is one super element that nature needs in abundance. And in nature, it never seems to run out. And that is phosphorus. So phosphorus element is abundantly available in the nature. Nature creates it, utilizes it, and recreates it. So that is called a circular economy of the nature. So we have to find out some solution from the nature by observing the nature, how to create it, utilize it. And normally what we do, lithium batteries, we utilize it and throw it away. But we can recycle the batteries and extract lithium and recycle the lithium and utilize that lithium again into fabrication of another battery. So efficient recycling is very, very important. For the country like India, recycling is very, very important. In our university, we have set up e-waste center, but they are also not up to the mark. But we have been telling them that focus our attention scientifically and technically so that you can recycle these precious elements which are otherwise going waste. One such example you might have seen in the last Olympics in Japan. Those gold medals, copper medals, and bronze medals they distributed to the winners of the Olympians were recycled from the West. And that was the classical examples. All of us in the world, the scientist responsibility is to find out the recycling protocol, efficient protocol, so that tomorrow the West would not be the West. We have to convert wealth from the West. And that can be a major thing. We can look around and see what are the things that we are throwing away from our house, from our college. For example, plastic is also, we are utilizing it. Once it is utilized, we are throwing it away in the environment. Can we recycle it? Because if we don't recycle it, it is going to make and create the problem. So today, I think in this particular conference, I would like to leave the mark onto the audience that they should think on how to recycle the waste and find out the material which is useful for recycling the waste. Of course, there may be several protocols, several strategies, several methods to recycle different things. Like for recycling the lithium batteries, we need to adopt different method, different strategies. If we want to recycle the plastic, we need to find out, do a lot of research in recycling the plastic, and so on and so forth. So for the country like India, this is very important. It is of paramount importance that we should focus our attention in recycling the waste. One such example I found, and that is from, of course, the pioneer is Indian woman, Indian scientist, settled in Australia. She found out green steel because she, right from the beginning, right from the childhood, she was obsessed with waste plastic. And finally, when she went to Australia, she did some experiments because when we burn plastic, you can get carbon, but that burning should be anaerobic burning. The burning should be pyrolyzed in the presence of inert gases like nitrogen and air. Then you can extract carbon and mix that carbon in the steel that can be called as a green steel. And she got a very prestigious award from the Australian government. So tomorrow again, we have to also find out some such procedures so that we can utilize the plastic into other things. In Shivaji University, in School of Nanoscience and Technology, we have undertaken such efforts and we are converting the plastic into the graphene and carbon nanotube. But we are still doing a lot of research work because, as I told you, there is a bottleneck to break. If I want to use this graphene into the battery, we have to do a lot of research into the graphene battery. Lot of people, lot of scientists in the world, they are utilizing this graphene for the batteries. But we have to find out the best batteries as efficient as possible to that of the lithium. That is the main challenge in the scientific field. So today we can replace the material, but the main challenge is with same performance, we have to design, we have to fabricate the device. And that is the main challenge in the field, in the scientific fraternity. These challenges have to be accepted. Of course, there are challenges and excitements in the scientific field. And in India, we should focus on all such things. And the main focus main message that I wanted to give you in this conference was how to recycle the West. So once again, I am thankful to the organizers, Dr. Zamdade and Dr. Sawant, who contacted me.
Hello, sir.
However, I could not come there because of my busy schedule. I sorry again.
Call anyway. So, so once again, thank you very much and wish you all the best. Thank you.
Thank you, sir. Thank you very much for your online guidance, which is very much useful and fruitful to us. Now, I would like to request our today's honorable president of the program, Professor Dr. C.D. Lokhande, sir, Director, CIR, DY Patil University, Kolhapur. Please come on the stage and give your valuable speech on the occasion of the national and international conference. Professor Dr. C.D. Lokhande, sir.
Honorable Principal Sir Dr. P.S. Sawant, the dignitaries on the dais. We have Dr. Katkar, Dr. Nanasaheb Thorat, and all the other conveners of these conferences. Well, just now we have listened a very important talk by Professor P.S. Patil sir, who is a Vice Chancellor of Shivaji University and a renowned material scientist. And he addressed few things. You mentioned about few challenges in the material sciences. And in fact, he put some of the questions and some of the problems before us, because this conference, part of this conference also addresses for the emerging trends in the material science. In fact, when we talk about the material science, it's a combination of many fields. For material science, we need physics, we need chemistry, we need biology, we need computer science, we need mechanical engineering, we need computer science and everything. So when we talk about the material science, it's not only the one topic. And therefore, when you address different problems and go for doing research in the material science, probably it is a combination of many fields. The student from physics cannot say that I cannot synthesize the material because I don't know the chemistry, or I cannot make the mechanical measurements of this material which I have prepared, which I have synthesized, because I am not a engineer, a mechanical engineer. So it's a combination of many fields. So those who are working in the mechanical, in the material science field, I think need to many things. As Professor Patil told about many things, he referred most of the time not to physics, but he referred many times to the chemistry, the study of elements. And he's rightly pointed out that now the
all the elements in the periodic tables are fixed. Is no such possibility of getting one more element to be fit in or to add in the periodic table. And for last few centuries, all the materials from the periodic table, all the compounds, they have been made from this combination of different elements of the periodic table have been studied well. So if you see that, there's nothing left about any material, about any compound from the periodic table, which we claim as a new study. But fortunately, in making these materials in small form, as we say, nanoscience and nanotechnology, have opened a new avenue. Because the properties which we knew, these are the properties of the bulk materials. Materials which are formed in the bulk form, whether it's an element or a compound. But if you reduce the size, their property changes. And therefore, this has made a new field, a new opening for the researchers. And as you know that, therefore, in the last few years, the most of the research in the material science has been concentrated, has been devoted only to the material, to the nanoscience field. So this is one of the things. Sorry. Another thing which I wanted to tell you today about the changing trends, not in the education, but in the research field also. Probably you might have seen the new National Education Policy 2022, where all of a sudden we have started talking about, not about the interdisciplinary research or interdisciplinary subjects, we have started talking about the multidisciplinary approaches. As we see that the material science is an interdisciplinary topic because it needs help of many fields. But if you talk about the multidisciplinary approach in the education, that means simultaneously you can study the science and a subject from commerce, a subject from the literature, a subject from law. And I think yesterday only we have new PhD guidelines. Of course, these are quite new. Yesterday only those guidelines have been appear in the Gazette of Government of India. I've gone through it and found that now the requirement for doing the PhD have been changed. All the guidelines are based on the multidisciplinary approaches, new stages that are coming in the education field, 4+3/5 and so on. So these are the new guidelines. But the basic of research remains same. Say, most of you probably who are doing in the last year of BSc might be doing some sort of the PhD, the research or project activity. Even for PhD, as far as UGC's policy concerned, what UGC is expecting for doing the research PhD work is the introduction to the research methodology, which means that UGC doesn't expect many things from you. What UGC expects that you should give a systematic approach, a scientific method for analysis of the problem for a given subject, whatever topic which has given to you, and how you handle it and tackle that problem. So even if you know the UGC guidelines 2026, 16 or 2022 now, even for this year's guideline, UGC is expecting for the researchers to develop a scientific approach to handle the problem. However, when we go a little bit further, we enter in the field of research and wanted to be there, making a career in the research field, then there are many expectations from you. Till today, when the NAC was not there, before the NAC, research was not a popular thing in the colleges or even in the universities. But when NAC came and criteria 3 appeared, then everybody started talking about research. Because there are some points reserved, maybe about 25% points are reserved for the research activities, extension activities, and so on, which was earlier was the most neglected field. Earlier, for the teachers, teaching and learning was the only thing which forms a part of about 20 to 25% in the NAC criteria, which means that we were avoiding about 80% of parts. But now when NAC came, when the concept of NRF ranking came, UGC made it compulsory, government made it compulsory, and now we started talking about the research activities. But I feel very happy that many colleges have accepted these challenges where the research was not done, where research was a neglected quantity, very few people were doing, and at the same time others were hating them because they are doing the research work, which is a nonsense at the college level. But now that has become a most respectable thing. And I think this college has taken up this activity in a very active way, where most of the departments are involved. Today we have a conference with physics, chemistry, botany, mathematics, zoology, microbiology, and so on, which means that most of the science departments have been involved in this activity. And I think this is a great success for this university and the leadership of this college also, because Professor Sawant has given a right direction that there is no other way to skip from this. Now you have to get involved in the research activities. So this is also an important thing, that this type of culture has been cultivated in the colleges. So this is one of the observations that I wanted to make. The another thing that most of the points which Professor Patil has talked about the super elements and so on. So this is a part of the game. Of course, this conference, even in this conference of this material science, you are taking care of all other aspects. I have gone through these different topics, and I found that most of the advanced topics have been covered in these conferences, which are something like the nanotechnology and nanomaterials, future smart materials, polymer science, energy materials and devices, biomaterials, and healthcare, and so on. And I am very happy that you also got the expert in the very similar fields, that the expert really in this field. And one classic example of such will be the Dr. Rana Sahib Thorat, who is sitting over here. He did his MSc in physics. He's a product of physics, a basic science. But now we have done a commendable work in the biomedical field. So there's a much more transition going from one field to the another field. So in research, nothing is untouchable. And there are a lot of opportunities for the applications of these new materials which you are going to make, probably in the form of the nanomaterials, and find their applications by revisiting the old applications. Because earlier where there were no solutions, there were restrictions, the research was stuck because of some physical constraints or chemical constraints of these materials. So that can be overcome because of these nanomaterials. We can do the wonders with these nanomaterials. And these nanomaterials have many applications in the field like medical sciences. So I'm sure that this conference will give some concrete ideas as an output. Probably some of you might get inspired for doing the research, not basically in the field of basic sciences, but in the applied sciences also. Even 10% students get inspired. I think that will be the success of this conference. Because we need sciences in very long, in a large quantity. We don't know how many people, how many scientists are working in Israel. Hundreds and thousands of scientists are working for that purpose. To develop a new material, there are a lot of difficulties, a lot of experimentation has to be done. Because earlier there were no success. Now you have to try in very different ways. Put some different approaches. And at the same time, also try to find the new applications. So we need the scientists, we need the technicians, we need large quantity. And as all of a sudden, probably you might have seen that from the 2016, when there is the IPR policy that has come up by the central government, there's a document published for that purpose. You will see that government has also changed policies. Government encourages to file more patents, more copyrights, go for entrepreneurship, go for the startups, have incubation cells. These were shebs were not heard earlier. But now that has become the essential for everybody, for every colleges. Probably your college is also having the startup activities, as Professor Sawant has told me. He is also working on different materials. He has also a startup. But now government wants such type of startups at any corner. And a lot of funding is available for such type of activities. So that is a bigger change in the government policies. There's a bigger change in the scientific field also. Now we are going from interdisciplinary approaches to the multidisciplinary approaches. And earlier, whatever there was the watertight, walls between physics, chemistry, and botany, zoology. Now the subjects like biotechnology needs many things. Probably that subjects you need the materials, the nanomaterials for the applications of forming the biosensors, immunosensors, early detections of some of the dangerous diseases like cancers, diabetes, TBs, and so on. For this, you need a material, even though it is a totally different field. That means there has to be a collaboration between many departments, so that the government will definitely support such type of proposals if they are having the departments more than one or more than two also. And talking about an output or an outcome as some sort of a device. So this is the necessity and this is the requirement of our country now. So I think this conference has been organized. I also thank the convener of this convener, Dr. Jamdari, all his colleagues, other conveners, particularly the principal of this college. Of course, we know each other in different capacities, in the university. But I am thinking that he's really a visionary person, and he has encouraged you for such type of activities. And therefore, I'm sure that this college will also come up in the research field also. Those colleges who don't know about filing the patents, I came to know that you have many patents to your college, you have many copyrights to these colleges, you have startup, you have different funding projects, and so on. I think this is a very great sign. I really congratulate the college for such type of achievements in the field of research. So with these few words, I thank the organizers for inviting me and changing my position from a speaker to a president at the 11th hour. Thank you very much, sir. Thank you.
Thank you, sir, for your keywords and focus on major events. Cultivate the habit of being grateful for every good thing that comes to you and to give thanks continuously. And because all things have contributed to your advancement, you should include all things in your gratitude. Let me invite Dr. V.S. Koshti to deliver a word of thanks. Dr. V.S. Koshti.
Good afternoon to all. Respected dignitaries, today's chief guest, Professor Dr. P.S. Patil, today event president, Professor Dr. C.D. Lokhande sir, college principal, Dr. V.S. Sawant sir, vice principal, S.D. Jadhav sir, Kolekar sir, Javade sir, and all the convener and coordinator of today's conference event, my colleague, participant, and student. I, Dr. V.S. Koshti, Assistant Professor, Department of Chemistry and coordinator of today's international conference event. I feel honored and privileged to get opportunity to propose vote of thanks on this special occasion. Today, we have organized international and national conferences. For this purpose, we have a chief guest virtually here and a president on dais. So I would like to thank today's chief guest, Honorable Professor Dr. P.S. Patil, Vice Chancellor, Shivaji University, Kolhapur. He delivered his keynote address on today's international conference. Thank you, sir, for your valuable time and guidance. I extend my thanks to today's event president, Professor Dr. C.D. Lokhande, sir, Director, CIR, D.Y. Patil University, Kolhapur. He blessed us with his presence. Thank you, sir, for your informative lecture. Also, I thank to Dr. Thorat sir and Katkar sir for his presence in inauguration function. Although we are here for a whole day, but you are here from morning, so I should thanks to you. I am very thankful to principals, directors, professors, associate professor, assistant professor, researchers, students who take part in international conferences. Thank you so much for your participation. And the last, I express my thanks to Honorable Principal Dr. V.S. Sawant sir, who motivated us and guide to conduct the international and national conferences. Words are not enough to thank their constant guidance and support to shape the conference. Thank you, sir, for your kind support and always being with us. I am thankful to all of you who constantly working from last few days. There are many names, so I could not, due to lack of time, I could not speak here, but I can say non-teaching staff, all teaching staff, and who directly and indirectly support for this conference. With permission of President, the inauguration function is over. Thank you so much. Thank you.
Here one information is there. All the students, scholars and professors, we have 5-minute break, but you still remain here in auditorium. We start our next session within 5 minutes.